Hi, everyone. Sorry about that, and thank you for joining us today at the second Virtual Precision Agricultural Conference and Ag Technology Showcase. I am Ainsley Andres, and I am pleased to introduce Jeff Chandler, who will be discussing Can Robotics Work for Small Farms? Take it away, Jeff.
A farmer, 11th generation farmer in the US, so I pretend like I know what I'm talking about. The company is a new company, and it was started 2 years ago after I had been working in IT for many years prior to that. The nature of the company is that we want to focus on solutions for small farms. So this topic is exactly where we are and what we're focused on. But a little bit different from other companies involved in robotics is the small farm aspect. It's really part of our mission. And specifically, our mission includes focusing on grain crops, but we're not doing weeding machines. We're not doing plant health measurement. We're not doing drones. We're focused on ground vehicles and finding solutions for small farms based on that kind of a technology. So I said, as our mission, small farms, but also important, we want the products to be affordable, and I think that's an important point to make. If our products are not affordable to the small farmer, then we're wasting our time. But we also see our products as not a single product, but rather a family of products that scale up based on the different sizes that the farm is involved in. Part of the secret to making it affordable is to try to build on existing components and use existing implements and attachments without reinventing every single thing. And really, we're getting into almost consumer grade products. So we're thinking about the distribution channels for the products as well, thinking about dealer networks, leveraging existing dealer networks, and even existing channels like retail chains, Tractor Supply Company, or even Walmart or Home Depot, that sort of thing. Okay, so what's the business case for small farm robotics? The reality is, in my opinion, a lot of the focus on agricultural robotics so far has been focusing where the money is, which is big farms, big fields, flat vegetables that are easy to pick, and in weeding in particular, the focus is really on fields that look a lot like this. That's not the case at all with small farms. Our farms look more like this. The perimeter is ill-defined. The rows are messy and not straight. The fields have a lot of stubble in them. And so it's just a different problem, particularly in the eastern US where I live. The perimeter of the field is uneven, and so the shape of the field is also an issue because it's not square, it's not a rectangle, it's all over the place. What we learned in doing some market analysis is that at least in the US and I think in other parts of the world, small farms are pretty important. The orange line on the graph here shows that about 45% of the farms in the US are less than 50 acres in size, and a good 13% of the farms are under 10 acres. And so there's a market opportunity on the small end of the scale, but can we really deliver products that make it economically viable? That's the challenge. In my own home state of Maryland, it's even more skewed towards small farms, and that's partly due to the fact that in the eastern US, the parcels of land are all cut up, unlike the Midwest or the big fields in California, like the picture I showed earlier. So again, we think there's a market opportunity here, but we have to figure out how do we really do it. The reason that we focus so much on grain crops in our analysis is because, again, in Maryland and in large parts of the eastern US as well, the majority of the farms are growing grains like corn, soybeans, sorghum, wheat, hay even, and that's again where the dominant part of the market is. Just in sheer numbers of farms, that's why we're focused on those types of crops. You can maybe see from the circled items on the right side, that's not necessarily where the big money-making farms are. In Maryland, at least, the largest revenue per farm is on nurseries, greenhouses, flower growers, and sod farms. But again, we're focusing on the grains, soybeans, those sorts of crops. So as you probably already know, the challenge for being a small farmer is you're working against the odds because the economies of scale just really favor large farms much more than small farms. It's difficult to get the volume of product unless you can change some of the dynamics. What I know for a fact is that just in working my own farm, trying to think about working it with robots, the processes of planting and disking the fields or tilling the fields just do not favor small scale robotics. They really favor the big tractors. And so that's something that we're thinking hard about. There are tasks that are suited better to small robots, and those are things like maintenance of the fields or crop monitoring for crop health. As I said earlier, crop health is not an area that we're particularly focused on, but we're thinking more about the maintenance tasks. But one of the realities in working a small farm is the logistics really favor using traditional tractors, because once you harvest the product, you still have to get it to the market. And so you got to get a truck in there and unload the hopper on the combine or whatever, and then take the product to the silo and unload it. The robotics is not going to really change those processes. So we have to think about where we can really make an impact. So let me just give you a little bit of an example. With a 10-acre field, let's say you're using a big tractor to work that field. To make the circuit for that field takes, let's say, 45 minutes. Tractor's running about 10 miles an hour. It takes about 20 minutes to set it up and take it down. But in my area in particular, one of the hidden time elements is the travel time. The equipment could be 10 miles down the road instead of around the corner because of the nature of the small farms. And so there's a real dynamic here with the need to travel to and from the field where you're doing the work, and it might take a half an hour each way. So that's really a time suck. Obviously, we're using diesel as our fuel. So compare that to trying to use a little robot. It might take 7 or 8 hours to work that same field. The advantage there is that I can do it pretty much anytime I want to. I don't have to do it during daylight. I could actually do it at nighttime if I had to. The speed is running 4 to 5 feet per second, roughly half the speed of the big tractor. But it takes far less setup time theoretically. And presuming that the robot is already on site, I've got no travel time at all. And it's all electric. So those are kind of the parameters that we're thinking about. And what we're really thinking about is breaking it down by type of task. So I said earlier, disking and tilling really favors the big tractors, maybe even small tractors, probably not ATVs, but really it's impractical to try to use a small ground vehicle for those kinds of tasks. But I can make an impact with other tasks, spraying, planting, fertilizing, and monitoring the health. But again, harvesting is really a task that's better suited to the big tractors. In my area, we use a lot of crop dusters and airplanes for cover crop seeding. I'm not sure that's true in other parts of the country, but cover crops is an area that we can make an impact on in not just ground vehicles, but also drones, as well as the airplanes. From an economic point of view, I'm thinking about how can we impact the operating costs with autonomous ground vehicles. Clearly, it can eliminate maybe 95% of operator labor. It does save fuel, but it has to be cheap electricity if I'm really going to have an advantage there. I have a hybrid car, and it actually costs more to recharge that car than the gas that I put in it. So maybe we're not there yet, but eventually we'll get there. In terms of acquisition costs, because we're working with vehicles that have a much lower price point, long term, we think there's an advantage versus big tractors. But the truth today is that big equipment manufacturers make it really easy to finance those tractors and implements. And also, the farmers are much more accepting of technology they're familiar with. So we have a long acceptance curve to think about in the future. Can I really change the cost factors? Yeah, I think I can in a couple of areas. With yield improvement, if I can improve the yield of my crop by 10%, either by reducing crop loss or boosting production yield, those are things that will make it more economically viable. On the expense side, yeah, I can use a lot less labor, but I think there's an opportunity cost more than a hard dollar cost in the time that it takes to have a human driving a tractor, getting it to and from the field, versus turning on a robot and letting it go to work. I know that there are companies that are focusing on highly focused fertilizing and focused pesticides. And I might be able to save on materials, pesticides, herbicides, and fertilizers. But again, I think it's at the margin. We're talking about maybe 10, 15% reduction in costs, not 100% or not 50% yet. There are other things that I can do on the revenue enhancement side. Just, simple things like you get more for your crop if it's at a certain moisture content, or in the case of wheat, if it has less ergot in the grain. There's subtle things that I can do, but I think the main focus for changing the cost factors is going to be in improving yield and cutting down on expenses. There are things that we can do that are more like farm management or a property management thing. I mentioned crop loss reduction, and we're talking mostly about animal control. We've done some experiments where we're targeting deer to try to keep them away from the field to reduce crop loss. And it's pretty interesting to play around with those things. It does work, but again, it's at the margin. Perimeter maintenance, we're talking about, basically walking the fence with a robot and detecting when the fence is broken or has fallen down or a tree fell on it, and alerting somebody that there's a problem. The same goes with trimming around the perimeter of the fields to keep tall grass down, and that has some benefits, but it's also the kind of technology that you can extend to just trimming along a road. It's really the same task. I think what we're finding is that thinking that we can completely change farm operations is just not realistic. We can't really change the fundamental farming practices, at least not yet. If we think about other crops, nut gathering, vine turning, there are other things that we can do, but right now we're just focused on the grain crops, and that's plenty of time. What we've done so far is we've developed prototype for a family of vehicles that are intended to be scalable, but the truth is that version 1 was an utter disaster. And so we have a lot of work left to do. The technical approach that we are using is, I think, pretty innovative. We have an adjustable wheelbase that allows us to change the size of the robot's wheelbase in real time. We're doing that in increments that make it suitable for grain crops, corn, soybeans, etc. It is a battery-powered vehicle with differential steering, a movable ballast to allow for good balance, and for the arms and implements that go on the arms, we have pretty flexible approach to that. What we're trying to do, as I said earlier, is use standard implements and adapt existing components rather than having to reinvent every single thing. We definitely have design challenges. Obviously, when you start out growing corn, it's really short, but in 6 weeks, it's 6 feet tall. And so you can't really see the rows anymore. You have to rethink about how we're going to navigate within the field and think about working a really tall crop. Anytime you have a robot running around cutting things or trimming things, you have lots of potential legal issues. So we're thinking about that too. We just have a lot of challenges, and that's why we're kind of struggling with version 1, getting to version 2. We think next year we will be in a good position to have a product prototype that's attractive to the market, but we're probably 2 or 3 years from really having anything that we can scale up. So in summary, I think number one, we recognize the logistical realities of just getting the crops to market. We understand that autonomous ground vehicles are not a replacement for big tractors, one for one. There's a place for robotics on a small scale in small farms, but it's probably not going to replace the primary farming tasks that we're still using tractors for, big tractors. And you know, we have our work cut out for us, but we're committed to it, and we think we're really going to make a difference. Sorry for the technical interruption. I lost my connection for a minute, but I'm happy to take any questions that you have. I think we lost the moderator too.
Hey, Jeff.
Nope, you're
Great.
back.
That's great. Thank you. Thank you for that. Yeah, so we can open the floor now to any questions. Feel free to post it in the chat. I don't see any questions at the moment, so. Oh, here we go. We got a question from Ross. He says, how much are batteries a limiting factor?
That's a good question. Right now, because we're powering the vehicle completely with battery, we're working on the assumption that we need to detect the battery life and have the robot go back home and plug itself in and then go back out. It favors having multiple robots in the field working simultaneously, but you know, we're looking at about a 4-hour realistic runtime at the limit, more like 2 hours on battery with good operations. That's kind of where we are right now. Well, thanks again for listening this morning, and be happy to answer any questions, follow up after the session's over.
Yeah, thank you everyone for participating. Thank you, Jeff, for your time. If you have a question that did not get answered or you want to connect with Jeff later on, head over to the networking tab and you can chat one-on-one there.